So today's lesson is a follow-up from our lesson on the sine law, and specifically we're going to look at an example of a word problem that involves you utilizing the sine law. Let's get right to it. This should be a problem that you include in your notes. So make sure you have your binder close by and that you're writing the question down. So perhaps pause the video now to write down the question and become familiar with it. Okay, so it reads, two ships are located 15 nautical miles apart. Okay, so I've got two ships. Ship A's angle to the entrance of the port is 55 degrees relative to ship B. Ship B's angle to the entrance of port 45 degrees relative to ship A. Whew, that is a mouthful. So I think the best course of action is to break this into small little chunks and then to draw a picture. And luckily part A of this question asks us to do that. But you may encounter problems where they don't specifically ask you to do this. I would highly recommend that you do. All right, so I'm going to start with this first little bit. Two ships are located 15 nautical miles apart. So I'm going to start by drawing a picture of that. So I'm going to go, all right, I'm going to say, imagine this is ship A right here. And then I've got ship B somewhere over here. Let's put it right here. And they are 15 miles apart, 15 nautical miles, but we'll just write 15 miles. And there I am so far. And so now it's telling me that they are somewhere at some angles away from a port. So I'm going to just put in the port. So I'm going to imagine that the port is like, you know, somewhere over here maybe. Okay, I'm going to call that P. And so now what I have is I have each boat being a certain distance away from the port. Okay, this is not a perfect triangle. I can't use a ruler on this, but let's just imagine that these are straight lines. And so here from the port to boat B, okay, or ship B, I should say. Now the next part of this question is saying ship A's angle to the entrance of the port is 55 degrees. So to me, that we're talking about this angle right in here. So I'm going to add that information into my diagram. Here I have, this is 55 degrees. And if I keep reading, I'll read that ship B's angle to the entrance of the port is 45 degrees relative to ship A. So that means that right here I have a 45 degrees. Okay. So now let's look. I've got a good diagram here. I've got ship A is over here, ship B over here, and they're 15 miles apart. And I've got my port over here, and each ship is a certain distance away from that port. Okay, so now let's move on to part B of this question. It's saying which ship is closer to the port entrance? So let's look at our diagram. Well, what distance is going to help me to answer that question? I need to know how far ship A is from the port. In other words, I need to know side little b. And I also need to know how far ship B is from the port. In other words, I need to find side little a. So it's important for us to remember that when I find side little b, that's actually telling me how far ship A is from the port and vice versa. So let's start this out. So remember, I'm using the sine law here. And so if I want to find out what side little b is right here, I need to know what angle B is, and I do, right? Here's angle B. So I'm going to set that up as the first measure. Okay, I'm going to say, well, sine of, oops, let me start that over. Side B divided by sine of little b. And I'm going to need to have another angle and side pairing on the other side of my formula here in order to work that out. And so far, the only side I have is this 15 miles here, which means that I need to figure out angle P. And using my triangle sum, I know that angle P is going to be equal to 180 degrees minus angle A, 55 degrees, and minus my 45 degree angle. And that's going to give me a total of 80 degrees. So I know that angle P is 80 degrees. And now I have an angle with the opposite side, and so that's going to help me to solve for this problem. So I know angle or side little p, this is little p, over sine of angle big P, right? Those are equal to each other. So let me fill in the information. So little b I know. Sine of big B is going to be sine of 45 degrees in this case. And then I'm going to put in the information for little p. Side little p is 15 miles divided by angle, sine of angle P, which is 80 degrees. So we've done this next step a lot. I know that to get rid of this divided by sine 45, I need to multiply by sine 45. And whatever I do to one side, I'm going to do to the other side. And so that allows me to cancel out my sine 45s. And now I have this expression for B, right? And so for B, I can now solve by saying 15 divided by sine 80 and then times sine 45. And the answer that I get when I'm doing that, and you should pause the video and try this yourself, and make sure that you're getting 10.8, and that's nautical miles. Okay, so now that we've found side B, right? Side B is, I'm going to write that in for us because we found it. We found that side B is 10.8 nautical miles. The only thing left to do is for us to solve for side little a, right? So we're going to solve for side little a, and that will help us to figure out how far apart our ships are from the port and then see which one is furthest away. So I want you to pause the video. I'm going to just erase this little bit here. And what I want you to try is to now solve for side little a. And I want you to think about, well, how are you going to set up your formula to solve for side little a? So pause the video and give that a try. And when you're ready, check the answer. All right, so I'm going to carry on with the solution here. So sine little a over sine of big A is going to be equal to, and I'm going to choose to use the same, information to solve for little a, which is the information that I have for side P. Oops. And so I'm going to go side little p divided by sine of big P, and I'm going to fill in my information. So a over sine 55 is equal to 15 nautical miles over 80, sine of 80 degrees. And same as before, I'm going to just multiply each side by sine 55 degrees. And that's going to allow me to cancel out my sine 55s. And I'm going to be left with A being equal to. And so when I work through the division here, so 15 divided by sine 80 times sine 55, the answer that I'm getting for side little a is 12.5 nautical miles. Right, and so let me erase some of this business over here. I'm going to get rid of all this. So now I found out that this distance right here from port to ship B is 12.5 nautical miles. So I want to finish off my word problem by making sure that I include a therefore statement to let the reader know that I know what the answer to this problem is. I've done the math. Now I need to write my therefore statement. Okay, and so let me get going. I'm going to write therefore. Okay, and so let's analyze. The question was, which ship is closer to the port? Well, I know that 10.8 nautical miles is shorter than 12.5 nautical miles. So that tells me that ship A is closer to the port than B. So I'm going to write that out. I'm going to say, therefore, ship A is closer to port. And I'm done. So hopefully that will get you started. I've created a worksheet for you, and you should be able to find that worksheet both on Google Classroom and a physical copy in the front office today. So make sure you go ahead and ask the front office for that worksheet so that you can complete the work. And we will see you on Monday.